Okay, it's 9:30. This is the V6 Ops Working Group. Welcome. Let us begin with our note well. If you have not seen this before, please read it carefully. Anything you say is a contribution to the IETF and will be treated as such. So read through this slide. Also, take a look at some of the rules that govern how we work at the bottom of this page, BCP 9, 25, 54, 78, 79. We've also been reminded by the IESG to treat each other with respect and courtesy. This working group has been pretty good, but a reminder never hurts. This is our agenda for the day. We have 3 drafts. The first, pros and cons of IPv6 transition and technologies. So I will stop sharing and invite the presenter to Gabor, you are the presenter? Oh.
Yes, I will be the presenter.
Yes, here we go. And your deck is being shared.
Pros and cons, this, I think it is. Yeah, share. Can you see my slide?
There it is. Yes, go on ahead.
Thank you. It will be a very, very short presentation. So I have only the main title slide and just one more slide. So it's because we feel that now our draft is ready for working group last call. We did 2 changes. So there were 2 places in the draft which were not ready and removed both. So it was section 4.2 about the issue of the scalability of the stateful technologies. And I opened a new individual draft for that. It's titled Scalability of IPv6 Transition Technologies for IPv4 as a Service. And here's a link for the 00 version. It has real content. So far, it contains the scalability results of IP tables, which is, of course, a NAT44, the stateful NAT44 implementation, but it serves as a sample for the NAT6 for scalability tests. And I would like to present it right after this draft. And there's another draft, but it's just a placeholder. It's about the benchmarking of all 5 IPv4 service technologies, which was referred in section 5. So now I think there's no unfinished parts. So I feel that our draft is ready for working group last call, and I would like to ask you to do that so that we can publish the document as soon as possible to assist the operators with a stable document. That's all.
See anyone on the queue, so I'm assuming there are no objections to a working group last call. Okay, I will start the working group last call next week. And I believe you are the next presenter too, no?
Yes. So I try to close the deck and try to open. How can I open the slides? Maybe I will ask your permission and then you give me the permission to.
Yes, here it is. I see the green check.
Yes, and scalability. Yes, that's it. And share. Good. Can you see the slides?
Yes.
Thank you. So it's a new draft. And as I said, it contains only minimum results. So in fact, this draft is about the scalability of IPv6 transition technologies, but so far it contains only the results for stateful NAT44 IP tables. And its main goal now is to serve as a sample for the measurements and for what kind of results can be presented. And I would like to ask the opinion of the working group if these kind of results are useful or not. And if not, then what other kind of measurements are necessary. And of course, we had a secondary goal because at the last IETF meeting, someone, I'm sorry, I don't remember who, asked if we could measure some results about IP tables. So I did so, but the main goal is to serve samples. And let me say some words about what I have measured. So the measurements are of two kinds. Scalability agents the number of CPU cores, how the performance of IP tables scales up with the number of CPU cores. And the other measurement is scalability agents, the number of concurrent sessions. Of course, number of concurrent sessions, when they increased, we expect that somewhat the performance will be decreased. And the entire description of the methodology is in this draft below. I have presented it on Monday in the BMWG working group, and the draft is there. So I don't want to use your time for that. Just some parameters and then the results. So I used 1, 2, 4, 8, and 16 CPU cores and measured two quantities. It was maximum connection establishment rate and throughput using bidirectional traffic as recommended by RFC 8219. And I used Dell PowerEdge servers with 2.1 gigahertz Intel Xeon CPUs. The clock frequency was set fixed to 2.1 gigahertz, and it has quite a significant amount of RAM. It was 384 gigabytes and used 10 giga dual-port network cards and somewhat old Linux version and Linux kernel. So here are the results. The first line shows the number of CPU cores. It was always doubled. So set using a Linux kernel parameter. So only this number of CPUs were on and others were off. And the first three lines shows the connection per second, median, minimum, maximum values. All the units are thousands. So it means that with a single CPU core, 223.5 thousand connections were established per second. And as you see, when we double the number of CPU cores, the performance doesn't really double, but scales up, I feel, quite well. So if you see at the end, with 16 cores, it's about 10 times as much as with one core. So I think it's not a bad scale up. And row number 5 shows the relative scale up. Of course, it is one with one CPU, and with 2 it's 0.83. But of course, it should be 1 if the number of connections would have been doubled, but it's less than that. And at the end, of course, it's about 0.666. So it means that with 16 cores, we can provide the performance 10 times as high as with one core. And below that, you can see the throughput. Of course, here is also median, minimum, maximum, and it also scales up very similarly. A very bit better, maybe the performance of 11 cores, but it's very similar. So it was the scalability agents, the number of CPU cores, and the other one is the scalability agents, the number of concurrent sessions. And the number of concurrent sessions was set by using different number of source port, destination port number combinations. And I usually increased the number fourfold, except the last case, you will see why. And also I increased the hash table size proportionally with the number of concurrent sessions, except the last two cases. And some non-uniform memory access issues also influenced the last case, you will see why. And I measured the same two quantities, maximum connection activation rate and throughput using bidirectional traffic as recommended by RFC 8219. And here are the results. In the first row, you can see the number of concurrent sessions, the number of source port number, destination port number combinations. And as you see, they were nearly always doubled, except in the last case. It was not doubled in the last case because it didn't fit in the memory. So when we used 400 million connections, then the memory consumption was below 150 gigabytes, and it was able to fit into the numerical memory, but when it was doubled, then it didn't fit into the numerical memory, but still fit in the entire memory. And as you see, the hash table size, we usually always increased it 4 times, except the last one case. So you see at 100 million, the hash table size 2 to the power of 27, and at 400 million, it's just 2 to the power of 28, because the system didn't allow me to set to a higher value, and of course it was not increased at the last column neither. So you can see both the connection per second median and the throughput median values. Of course, compared to the first column, in the second column, there's some decrease can be observed. As Rohan suggested, it's very likely due to the effect of the cache, because at the first column, the level 3 cache helped somewhat, but no more after. But from the second column, in the consecutive columns, the value is very, very stable. Of course, there are very little decrease in the last but one column, and there's some decrease at the last column, of course, because I couldn't increase anymore the hash table size, and of course, there were numerous issues. So for this reason, there was some degradation. But in general, we can say that using hashing, we can make good scalability. Of course, it's also true that a stateful operation has its price. We have seen it in the CPU core scalability, and also we can see it here because it requires a lot of memory. So with other solutions, we don't need such amount of memory. And we can also see that when we are approaching the limits of the system, for example, when we use non-numerical memory, then it's a problem, and it really becomes a bit lower performance. So this is the price of stateful operation. So I have prepared another slide with my questions. And my question is, what's your opinion? Are these results useful and sufficient for network operators? So using these results, you could make a good decision. And even it is more important that will the same method be appropriate for the stateful NAT64 scalability measurements? Because if you say it's okay that I start with measurements with that, and the first implementation is Joule. What do you think of Joule? Is it the right idea to test Joule? So that's it, and I'd like to ask for your feedback.
Okay, thank you very much. And I'll be looking for hands raised. Zhao, is your hand raised to make a comment on Gabor's? Or are you the next presenter? Are there any comments on Gabor's presentation? Okay, I don't see any. So we will move on to the next presentation. But before we do that, I'll note that Fred Baker seems to be having some problems connecting. I see him coming in and coming out. It's coming in and dropping off. So Gabor, if you could stop sharing.
Yes.
Okay.
Thank you.
And Zhao?
Yes.
You could start sharing. There we go. Deck is loading. There it is. Go ahead.
Okay, thank you, everybody. I'm here to present our draft, the ND deployment draft. The title of the draft is Isolating Hosts in Layer 2 and Layer 3 to Simplify ND First Hop Deployment. From the comments of Ted Lemon, we realized that this title may lead people to believe that we present a new solution in this draft. Which is not the case. This is a deployment guideline draft. So all the solutions that the draft discussed, are existing, RFCs. So this is the first clarification I would like to make. Also, the title may lead people to believe that we favor layer 2 and layer 3 host isolation all the time. This also not the case. We advocate layer 2 and layer 3 isolation only in the suitable cases. And the draft clearly say that, in what cases isolation is suitable and in what cases isolation are not suitable. So this is the first two clarifications that I would like to make about the draft. So first, I would like to talk about why we want to write such a draft. It's because we realize that many operators are finally starting to deploy IPv6. So in this process, they started to care a lot more about neighbor discovery, and they find that there are the issues and solutions are distributed in many RFC, and they will have to read many RFCs in order to understand all the issues and get comfortable with ND. So from talking with them, we decided that it can be useful to collect all the issues and solutions into a single place for easy reference. We acknowledge that RFC 6583 and recently 1999 helps because these two RFCs they talk about ND issues. The second RFC actually talk about IPv6 security issues, but it covers some ND issues. But nevertheless, they are either a little bit old or not complete on ND. For example, RFC 1999 actually didn't cover WING, the wireless ND. So I think that this is one hole that we are trying to fill. Second one is that currently there are these RFCs talking about ND issues, solutions. However, there's no draft saying how to avoid the issues, because if you can avoid the issues, then it will be simpler than living with the issues and then deploy a solution to deal with it. It's for this reason that we wrote this draft. And then the work part is kind of like a simplified table of content, what we did in the draft. So in the draft, first we summarize the existing issues, and then we also analyze the existing solutions. So I think that this will make it easier for people who want to, kind of like get an overview of all the ND issues solutions to have, basically a single place to go to. And also from analyzing the existing solutions, we distilled the wisdom from these RFCs, and we summarize it to a simple sentence that in many cases, if you isolate the host, then it can be quite effective in preventing the ND issues. But also, as I said at the beginning, we recognize that isolating hosts has its benefit, but also has its it can also cause issues. For example, if you isolating hosts, then if your service rely on, for example, NDNS, then NDNS is not going to work. So we do recognize that, isolating host has its, applicability. Some places it's good, some places it's not good. So we do discuss, where you should be isolating, where you should not be. This is the second part. And then we realize that, when you do this kind of like isolation, it may have an impact on other component of IPv6 first hop. So, including the addressing scheme, just now we talked about MDNS, etc. So these are briefly analyzed in the draft as well. So what's unique in this draft is that we are the first one to clearly distinguish L2 isolation and the unique prefix per host. With the unique prefix per host, some people actually in our draft we call it L3 isolation, because from our discussion, even among the co-authors themselves, and also we are seeking private comments from some experts in the working group, we find that many people mix these two things together. So L2 isolation is I think that is simple, right? It's like putting a host, for example, in a P2P link, or by itself, isolating from other hosts. Unique prefix per host is also simple. Is that each host get its own subnet or prefix. Some people kind of feel that, if the host is on its own link, then it will also get its own subnet. But this is not the case. So here we put on a picture that we take from RFC 7668. And this picture clearly tells you that, in this picture, the 6LN is the 6 low power node, and the 6LBR is the router. And here you can see that all the hosts are clearly, in a point-to-point link to the router. So, they are isolated in L2. But actually, RFC 7668, the author of that RFC, they decided that, for whatever reasons, it's better to put all of these in a same subnet. So again, this is a clear example that, just because a node is in its own P2P, for example, a P2P link, doesn't mean that, they will necessarily, has its own subnet. And we believe that, in this notion, if we clearly distinguish this, it will help in many discussions, because we actually discover that, even in RFC 8273, which is the unique prefix per host RFC, it's kind of like, implicitly assuming that, okay, the hosts are isolated in L2. Strictly speaking, there's corner cases where, the host may not be isolated, or vice versa. We also find that, there are some other drafts which, is advocating layer 2 isolation. For example, P2P Ethernet, the author assumed that, it will automatically imply the unique prefix per host. We would just like to point out that, there are corner cases like this one, where these two things are different. So I think that, this may be a good notion for people to, for easier understanding of ND. And then we clearly, in this draft, we clearly analyze the pros and cons of both L2 isolation and unique prefix per path, and where they are applicable. And I would like to especially mention that when the unique prefix per host, before it became RFC 8273, there was actually a lengthy debate about the merit of a unique prefix per host. And at that time, many experts, is plus very good, insight about ND. But those insights are dispersed in, more than 100 messages. And, it's not easy for people to get, because people may read RFC, but they may not go back to, historic mail archive. So, while we are writing this draft, we go to this XCU, and then we carefully read all those messages, and we also summarize the valuable insight from that, 100 plus messages into the draft. Again, I think that this will help people to get some of the insight from the expert, and this will also, help them, understand the pros and cons of unique prefix per host better. So this is another one. And overall, this draft discuss, how to avoid NDXCUs and then provide the deployment guidelines. We believe that this is useful service to the community. And then on my last slide, I would like to give some suggestion on how to reading the draft, because from our the mailing list, a couple of people have read the draft, but we believe that many people may still have not have a chance to read it. So based on discussion with other commenters, we realize that again, some people think because of the title that we are advocating host isolation everywhere. Then I think that people may get alienated, about the draft immediately. But here I would like to clearly clarify that this is not the case. We realize that, again, host isolation has its merit somewhere, but, may have disadvantage otherwhere. So, it's only, we do have some guidelines on where to apply this host isolation. And then, it's important not to assume that L2 isolation automatically imply a unique prefix per path. These are two different things. Because if you feel that these are the same thing, then our draft may appear a little confusing. That okay, why you are kind of like treating them differently. And also, we recognize that ND is a very complex protocol. When we talk about ND, it's very easy to make mistakes. We also acknowledge, or at least, I don't want to speak for my co-authors, but, at least for myself, I'm not a well-known ND expert, like some of the people in this working group. So sometimes, people may think that, oh, when they have a disagreement, they say that, oh, these guys are, newbies and they know what they are talking about. Now here, I would just like to highlight that we did many months of fact-checking. At the end of the day, we may still make some mistakes, but we shouldn't be making too obvious mistakes. So, please give us some benefit of doubt. Bear with us a little bit. And with that, I would like to say to the community that please review and comment. We would really appreciate that, because we put a lot of effort, and we believe that this draft is a good service to the community. We didn't advocate any solution, so we don't have our own agenda. We just want to help people understand ND easier. And we'd like to thank Ted Lemon and Brian and Michael for their comment on the mailing list. And also there are the private commenters, which we appreciate. And also, if you really, if you feel that this draft, you can also contribute to the draft, we welcome your contribution. And, if you want to be a co-author, we are also open to that. And that's it. Thank you.
Well, thank you very much. And I see a few people in the queue. Dave?
All right. Yeah. So good presentation. So thanks for putting your efforts into this. I think my comment is related to your original point about it's really hard to find all the information because it's scattered around a bunch of drafts and you don't know where to look. My comment is that there's an IEB RFC that I think would be good to reference, and that's RFC 4903, which is called Multi-Link Subnet Issues, right? That's what the IEB did an evaluation of the issues around multi-link subnets and at least wrote those up, right? It again did not, I guess you can read it and decide whether you think it actually makes any recommendations or if it just highlights issues, right? And so I think it's another good reference to add to your list because it will point out some of the things that you're pointing out and maybe some other ones that you don't have in your draft. Since I scanned through your draft, but I didn't read all of it. But I did look at your list of references and noticed it wasn't in there. So I just wanted to highlight that draft and suggest that you add that one as another one of your references. Just to your point that it's really hard to find all the right places to look. So.
Okay, thank you, Dave. 4903. Actually, you know, in our writing, we actually did come across that one. So we'll think about it and then add it to the reference. Thank you, Dave.
Okay, Nalini. Nalini, you'll have to push the microphone button so we can hear you.
Hello?
Now we can hear you.
Okay, great. Yes, thank you so much for doing this work. I'm working with lots of enterprises. We've been trying to get them to implement. This is big area of confusion and problems. And so I will have people that I know, very large implementations, also take a look at this and see from private managed networks, see where this makes sense, and we will give you feedback. But thank you for doing this.
Thank you very much, Nalini.
Jen?
Hey, hello. Yeah, thanks a lot for doing this. Very interesting. And I'm particularly interested in think about what you call layer 2 isolation. I'm just curious if you talk about something like private VLANs, when from router perspective, it's still a single interface, right? And it's just your switching infrastructure preventing peer-to-peer communication. I assume this still does not prevent an attacker from doing, from poisoning neighbor discovery cache on a router, right? Because nothing prevents host A start sending NAs with host B addresses, right? Even if they cannot talk to each other, they both can send traffic to the router. So I'm just curious how layer 2 isolation in this case helps with ND-related issues. But if it's different interfaces from router perspective, right? I'm curious how well it would scale, because you might have like thousands of hosts in VLAN currently. And if you start creating interfaces on a router for each host, I don't know if it exists, because if I look at this from enterprise perspective, I have a VLAN currently, and I would like to see something like prefix per host and so on, but I'm not sure that technology actually exists. I'm just curious if you know about implementation of those things in like normal routing switching environment, and if yes, it would be very interesting to see like deployment recommendations, because I've never like come across anything like that.
Yes, Jane, thank you very much for your comments. I think that you are right. I have two feedback. The first feedback is regarding, okay, so if you do the L2 isolation, first, you may require many interfaces. Second, even if you do the L2 isolation, you know, other hosts in another P2P link may still poison the router. I completely agree with you. So my first feedback would be, just because you do L2 isolation doesn't mean that you automatically solve many ND problem. When you do, for example, no matter L2 isolation or unique prefix per host, actually you also need to enhance the router. Otherwise, just isolation themselves, may solve some problem, but does not solve all the problem, like what you just mentioned. So I think that what I'm trying to say is that if we look at the L2 isolation and also unique prefix per host, all of these also require that the router have additional functionality for the final solution to be clean. If you just do the L2 isolation, or you do unique prefix per host, but if you don't enhance the router, then there is still many problems will remain. For example, if we look at the L2 isolation case, which I think that if we look at which solution make use of this one, I would say that a case in point would be the wind, the wireless ND. And the wireless ND actually, introduced quite some, new functionality into it in order to, avoid some of the problem that you just mentioned. I think that this is my first response. And the second response regarding the introducing of, for example, many interfaces, this may be the case, and this may be something, undesirable. But, in our draft, it's largely we talk about the where it's appropriate, where it's not appropriate, and if introducing too many interfaces become a problem, then I think that in our draft we will recommend that you don't do it. I hope I respond to your points.
Mostly, yes. So I'm just curious. So when you're saying you need to enhance your router, you basically, are you saying about any existing technology which could be deployed by a random enterprise, or you're talking about something which doesn't really exist currently?
Well, if we go back to the debate before UPPH become RFC, I think that the people, for example, I think that the author of RFC 8273, they say that the implementation exists. However, how exactly should the implementation be was actually not clearly specified in any RFC. So personally, I believe that this implementation, for example, I think that for L2 isolation, Wind clearly specify what additional functionality the router or the host needed to do. For example, in Wind, they specify this address registration. But I think that in the case of UPPH, what exactly should the router do is actually not specified. And I actually feel that maybe we need a draft. And actually, OLA's P2P Ethernet draft, personally, I think that can actually be the mixing specification of RFC 8273. I don't know whether OLA agree to this or not, but personally, I believe that the implementation of unique prefix per host is actually mixing, is not specified in any RFC, even though the vendor may have it.
Okay, thank you.
Okay, Eric?
I'm slightly concerned by how much wind has been thrown around in the last few minutes. I also think more generally, it's probably going to be more confusing for operators to have all the 6LO stuff mentioned in here, right? Wind is, I mean, I know Pascal's on the call, but like the stateful 6LO stuff, the stateful registration stuff that 6LO does was discussed in 6man in the past. You might want to go review some of those discussions. it was not adopted as a host requirements implementation for general purpose wireless, right? So I would maybe see if there's maybe reconsider how and when to clarify that, you know, wireless ND here is like the stuff that you're calling wireless ND is 6LoW specific at the moment.
Okay.
And I think it's probably going to be confusing when operators find out that there is no wireless ND address registration stuff that they can force on 802.11 enterprise networks, for example, or that hosts don't implement it at all, for example.
Thank you, Eric, for the information. I think that this 6LN, I put it in this slide, but it's actually not in the draft. But in the draft, we did talk about, you know, WIND, the few RFCs that already published by the IETF. I think that maybe I will talk to you offline to see how to address your concern.
Well, so yeah, this 6LoW diagram doesn't appear in the draft, but like there's lots and lots of WIND recommendations. It looks like to me it looks like the draft sort of yeah, I mean you do mention that it's appropriate for 6LoW cases, for LLN cases, but I'm not entirely sure it's going to be clear to an operator that this stuff is not available for like laptops and whatever, generally speaking.
Yes, but I'm just thinking that some operators are starting to do this IoT. I must admit that, you know, I am not an expert here, so maybe I do some, you know, offline discussion with you to see how to address your concern.
Fair enough. And here's Pascal. Thanks.
Pascal?
Yes, can you hear me okay? Oh, I'm getting...
Yes, but you are breaking up.
Yes, it's because of my source. I'm sorry. Yeah, I think we'd never really resolved whether wireless ND is applicable to general purpose. I mean, there were very few discussions. There was never a call for adoption. Really, there was not enough discussion to justify that any decision was actually taken. And really, we would need to study the prime at 6-man, which was never done.
Okay, why don't I propose that the three of you, Eric, Pascal, all get together and discuss whether WIND should be, and Zhao, all discuss whether WIND should be included or not, or, you know, how it should be. Pascal?
Yeah, I would say that also there are a number of new documents which extend the same registration mechanism of our different technologies. The most recent is EVPN. So yes, it could really be something very useful to IPv6.
Okay, Eric?
I think it's fair to include it. I just think it's got to be highlighted that for operators that just sort of might assume that this is the way, that this is an option that's available to them or a knob they can turn on when that's not necessarily generally the case.
Okay.
Thank you.
Any
Eric.
more comments? Okay, thank you, Zhao. And that is the end of our presentations for the day. I have one, well, first, do we have any more general comments about anything for the working group? Okay, looks like we're all happy campers. I have one announcement before I close down the meeting, and that's that we will have a second session tomorrow about the future of the IPv6 hop-by-hop extension header. That will be a joint session with 6-man. I think we're all aware of the current condition of the hop-by-hop extension header. Many providers drop packets that contain hop-by-hop because it can be used as a DOS attack. We're finding some new uses for it, but we really can't use it because of its status as a DOS vector. So there will be a joint meeting between V6 Ops and 6-man tomorrow to discuss discuss how we can fix that problem. With that said, we have a few more minutes. If anybody has a topic to bring up, I'll wait for the queue. Looks like nothing there. So I'll see you all on the mailing list. I believe I have one action item to start a working group last call for the boards and draft. And you should all see that on the mailing list Monday. Take care all, and I'll close down the meeting now.
Thank you.
Bye now.